Hi, this is Sal Ferrara from the Electrical Training Center, and today we're going to be going over some important changes in the 2017 NEC. What I'm going to be explaining today is Article 200 and the most important changes there were in Article 200. So let's start right now. I'm going to share the screen, and we're going to go right into it. So here it is, Article 200, and there are certain important things that you need to know about this. So let's go into this, and I'll show you exactly what's important in Article 2, Chapter 2. So here you could see some of the changes. You have here 210.8, A7, 210.12, 210.52, 210.4, 210.70, and 210.71. So let's go through these, each one, and explain these important changes. First, we're going to go to 210.50C1, which talks about ungrounded conductors. And basically what this says is very simple. If I have two systems in a building, not residential, this is more commercial, and it's existing, let's say we have a 12208 system. Now I want to increase and put a transformer in and up it to 277 480, maybe for motors or lighting and something like that. You have to identify that new system, and you have to identify that new system. So you also have to mark it also. So it's very important here, must identify only the newer added system, which is very important. And also you have to make sure that it's labeled sufficiently. Okay, so these are very important things when we actually go and we do the installation. So an example would be the white wire, the grounded conductor. So if I have 12208 and it's a white wire for your neutral, your grounded conductor, then the 277 480 must be gray. So these are the things that this article will be going over. Okay, it's very simple and but a major change. And again, you can see here is existing, that it'll have to be marked, but the new ones have to be marked. Okay, very important. And it's also at all terminations connected in splice points. Here's an example, 12208, and now the 277 480, and you notice it's gray, and the ungrounded or the phase conductors are also different colors. So if somebody knows they go into a box or a panel, they could see two different systems. Another change was when we get into solar, basically PV, direct current, what happens here is they're talking about 60 volts for the ungrounded conductor for the DC. So before in the code, I think it was 50 volts, and they upped it to 60 volts. Where a branch circuit is supplied from a DC system operating at more than 60, each ungrounded conductor should be identified. So you can see here, they use the black for negative and the red for positive, or the conductor could have an N with a line which is negative and a plus for positive. So it doesn't have to be color coded, but it can have a negative and a positive to identify the DC conductors. Talking about now we're in GFCI, another important code change was that you take the shortest path measurement. How do you measure from a receptacle to a such as a sink that would qualify for GFCI protection? And what the code is telling you, must take the shortest path to connect to a receptacle without piercing a floor, wall, ceiling, or a fixed barrier, or passing through a door, doorway, or window. Passing through a door is like going to a cabinet. You know, you have cabinets in your kitchen. You can't just go through the cabinet, so it doesn't qualify. So you have to make sure that you don't have any cabinet space. So if you're going through, it would not qualify. So this is now a new requirement in the NEC. So if you look, and we'll get back to it a little later, that's the requirement in 210.8, the measurements. Another change was that they added E 210.8A to E. In the 2014, it was A through D. Now they added E, and we'll go through that, what E is. And also, all GFCI protection must be readily accessible location. When I say readily accessible, it's the actual mechanism, either the push button or the breaker. So if the breaker's in a panel, it's readily accessible. Just turn it on and off. If you have the where you have to push for the actuator, okay, that has to be accessible. Okay, you have the test button and everything, that has to be readily accessible. Not if you're downstreaming, you have a receptacle on GFI, that doesn't have to be accessible, readily accessible, but the actual actuator that you turn on and off has to be. Okay. And here we go back to the readily accessible, and you could see it'll apply for A7, A9, and B5. And this is how you measure. You measure from the edge of the sink to the where the receptacles, and if it's 6 feet or less, you're going to need GFCI protection for that receptacle. How you establish it, it's up to you. You can either put a breaker in, you could put, when I say breaker, overcurrent protection, or you could put a receptacle that has a little actuator, test button. But that's up to the installer. Okay, again, these are all where GFCI is required in dwellings, bathrooms, garages, outdoors, A3, crawl spaces, A4, unfinished basements, A5, kitchens, 6, wet bars, sinks, 7, boathouses, 8, bathtubs and shower stalls, A9, A10, laundry areas. D is dishwashers and lighting outlets and crawl spaces, which we'll talk about. D, and of course, swimming pools, which is Article 680. Okay, and we'll talk about that. And here's a picture of a GFI breaker. Remember, very important, your squiggly white wire or your grounded conductor always goes to the neutral bar, and your home run coming from your branch circuit, wherever your loads are coming from, to your home unit is called the home run. That goes right onto the breaker. Okay, so it reads right through the neutral of your breaker. That's how GFI works. Right? So in A5, all they did a code change, not major, but they have it here, that they added the word unfinished portion of a basement not intended as a habitable room. So if you have a basement, like you can see here with the hot water heater, this is unfinished, so they're going to need a GFI here. In the middle, you see a TV and everything isn't required. And over here where the work area is, and also a washing machine in this area where it's on, the floor is cement, cinder block and everything, you're going to need GFCI protection if you install a receptacle in that area. Now, again, just by code, you're going to need at least one receptacle in an unfinished basement, at least one. Okay? So when you install that receptacle, it should be GFCI requirement. In the 14 code, they took this out where they had the sink and the what they did in this 17 code, it wasn't the bottom of the sink they cared about. They cared about the top of the sink up here. Okay, so if you look right here, what they were talking about is up here, the top of the sink. Okay, not the bottom. And the issue was that there was a clarification on that. So in the 14 code, you could have did this. You could have put the compactor on GFI, and it was not that it was a bad idea, but the code wasn't clear. So the authority having jurisdiction said, you know something? It said the sink, and it didn't clarify if it was the top of the sink, the bottom of the sink. So it didn't matter what part of the sink, as long as you're within 6 feet of the sink, you needed GFCI protection. But they clarified that in the 17 code, and you don't need it anymore. So it's important to understand that. So they took that out in the 17 code. And here you could see that underneath here you don't need it, but here's the top of a sink. Okay, at the edge of the sink, and that's the key word from the top. inside edge of a dwelling unit sink. From here to here is 6 feet. You're going to need one. So if they put this receptacle, just show it to you. You just get this. If I put this receptacle over here, and from here to here, say is 7 feet, then I don't need GFI protection. Say there's a refrigerator here. There's my refrigerator, and I put it here at 7 feet. I wouldn't need it. But if I left it here, okay, it had to be GFCI protected. The problem with this one, if you could see right here, it looks like it has the actuator. So this would be a violation because if the refrigerator was behind here, you couldn't have access to test the button. So in this situation, I would put a GFI breaker and just put a regular receptacle here. There was a refrigerator going there. Okay, if there's no refrigerator, again, you just measure 6 feet, and whatever that 6 feet is, which is 6 feet or less, then you would need GFI. Okay, so that's how you test, and that's how you would figure out if you need GFI. So here you go, GFI, and you could read this. GFI is required here, and this one over here. You might need it here. And again, if you measure from the top edge, and you go all the way down to here, and from here, if this was 7 feet, no GFI, no GFCI protection. Still has to be on a 20 amp circuit, but no GFCI. But if this was 5 feet, then this would have to be GFCI protected, and it's up to you as an installer, either a breaker, overcome protection, or a actuator. Okay, very simple. And again, in 210.8A10, all laundry areas, anything in the laundry area, not the sink, but in the laundry area, must be GFCI protected now. Okay, any receptacle installed in that area, and this is a whole area, not a room, but an area, must be GFCI protected. Okay. There's another picture. So all these receptacles here have to be GFCI. Not the dryer, but all 125 volt, 50, 20 amp circuits. Some more pictures. These are all GFI protected. So they probably have an overcurrent protection device in the panel. 210.8b, a GFCI required in commercial, 3-phase receptacles, 150 volts or less, and also 100 amps or less. So if you have you're working in a mechanics place or something, and they have a machine like this now has to be all GFCI protected. All single-phase receptacles have to now be GFCI protected. Other than dwellings in a crawl space, now you need, again, GFCI protection in a crawl space. Okay, so that's very important. Up to 100 amps or less, and also 150 volts to ground also. Okay, so these are the requirements now for a commercial building. In doubt, put GFCI, especially in commercial in the crawl space area. And here's another picture of it. So here you could see a receptacle here, and in this area you're going to need it, and also on the right side you're going to need it also. That's in B10. The dishwasher, you're going to need it, and it was in the 14 code, but it doesn't matter if it's hardwired or both the receptacle. You're going to need GFCI protection for the dishwasher. Okay, either way, you're going to need it. Doesn't matter. All outlets. So it could be a receptacle, it could be hardwired. You're going to need it for the dwelling unit, kitchen, dishwasher. Okay. So here you could see there's a box behind here. What a lot of contractors will do is they'll drill a hole through here, run the cord, put it to a receptacle right here, and this is accessible because once you open the door, you could see the receptacle, and it has to be GFI. Again, that you could either make it a breaker or make the receptacle GFI. Okay, so that's another way you could get around it. Here's a picture of, again, if you're going to put GFI, you would have to put a breaker in here, or you could put a cord and put it in this cabinet to the right. Last topic is also now crawl spaces. All crawl spaces, doesn't matter residential or commercial, you're going to need now for the lighting, not receptacles, but for lighting, GFCI protection for the lighting of in a crawl space, okay, all lighting outlets. And what happened was, just a quick story, an HVAC contractor was in a crawl space, he touched the duct just like this and he got electrocuted. Because somebody dies, this goes into the code. So all lighting outlets in a crawl space need to be GFCI. Okay, and here's another picture. So these are some of the important changes, especially in 210 that I wanted to go over. So I hope you enjoyed it, and come back to the school, call me or call the school, and we can actually do a seminar for you, your workers, or anything, you know, whatever you need, we could do. So I want to thank you, and I hope I see you soon. Have a great day. Bye-bye.